right, y'all, today we're looking at notes 1-4, inverses with composition. So before we get started, I want to make sure that your name is in the upper right-hand corner in pen. So let's get started. F and F inverse are inverse functions if, and no, I didn't misspell if, that stands for if and only if, okay? F composed of F inverse of x equals x, and F inverse composed of F of x equals x. So that's a mouthful, right? What it really means is F of F inverse of x equals x, and it means F inverse of F of x equals x. So basically, when you plug the two equations into each other, they both must equal x. So I know that's a mouthful, but I promise by the end you'll really get the hang of this. Okay, so examples. Use composition to determine whether each pair of functions are inverses. So are f of x and g of x inverses? That's what it's saying. Determine if this pair of functions are inverses of each other. And so what that means is we need to find f of g of x, and we need to find g of f of x, and those two things need to equal each other, and it really needs to equal x. That's what it means. Okay, so let's find out what those things are. So let's first find f of g of x. It doesn't matter which one you do first. Okay, so remember, we work our way inside out for these composition problems. So I'm going to first plug in what I know g of x is. So that means I'm going to have f of, and g of x is 2x plus 6. So I've substituted in the inside. Remember, I like to use the brackets. In the inside, I have plugged in 2x plus 6 because that's what g of x is. And then that means, because I can't simplify this any further, I need to plug in this into the function of f. So the function of f is 1/2 x. So where I see x, I plug in 2x plus 6. Okay, so 1/2 x minus 3, because now I'm doing the f function. And then I need to just simply compute this. Okay, so this would become 1/2 times 2 is 1, so that's just x. 1/2 times 6 is 3. So we have x plus 3 minus 3. Of course, that's 0. So f of g of x, of course, you would use proper notation and drag that down. F of g of x does equal x. Let's see if g of f of x also equals x. So let's try it. So does g of f of x equal x? So now in this case, f of x is on the inside, so I'm going to do g with my brackets, and then f of x goes on the inside. Okay, and then that gets plugged into g. So here's g, so that's 2. Where I see x, I plug in the 1/2 x minus 3, and then plus 6. And then, of course, I just distribute. Oops, I want to be consistent, so I'll use the blue. Of course, I just distribute. So this is 2 times 1/2, that's 1, so that's x. 2 times -3, so that's -6. So I've got x minus 6 plus 6, of course, that's 0. So in fact, g of f of x does equal x. So what does that mean? That means that f and g are inverses. Okay, that means that f and g are inverses. All right, let's move on to the next example. So are these two guys inverses of each other? Let's see. So let's first compute f of g of x. And again, it doesn't matter if you do this first or the other one first. Okay, so f of g of x means f of, let's plug in g. Remember, on the inside we get g, so that's x minus 5. Okay, so now I'm going to take this and I'm going to plug it into the f function. So the f function is x squared, so where I see x, I'm plugging in this. So x squared minus 25. Hopefully you remember that 2 up there. It means you've got 2 of these. So x minus 5 times x minus 5. That's what that means. And then you're going to double distribute. So x times x and x times negative 5. So x squared and then negative 5x. And then I'll use a different color here. Negative 5x times positive 25 or plus 25. And then drag down the minus 25. So this kind of got, I don't like the way that looks. Sorry, I'm being picky. There we go. Better. Better, better, better. Okay. All right, so now I'm going to clean this up. I'm going to get x squared. This turns to minus 10x. And of course that turns to 0, but there's nothing else I can do to clean this up. So that means f of g of x does not equal what we want it to equal. F of g of x does not equal simply just x. So therefore there's no reason for me to even do g of f of x because I already know that f of g of x does not just equal x. So I can say right here, f and g are not inverses. Okay, when the first one doesn't even equal x, the first composition doesn't equal x, you don't even have to go any further. You can just say those two functions are not inverses. Okay, so let's try one more example. So here we're going to first do f of g of x. So remember, start on the inside. So that's f of g of x is 3x plus 28. Which means plug this into f. So f is this right here. So the 3x plus 28 goes where I see x, so that's in the numerator, divided by 3 here in the denominator, minus 28. So remember in a previous video we saw this, I think it was the slope video, actually I know it was, and this is where you share the love. So here you get 3x divided by 3, which is just going to be x. But then you have 28 over 3, so that's going to be a positive 28 over 3. Unfortunately, that doesn't simplify. And then minus 28. And again, here, these two things don't add up to 0, so our final answer is not just x. I mean, we can do this math. It's not really, here, I'm going to erase this. It's not really worth it because, again, I know that these two values here aren't going to add to 0. So I can really stop right here because I already know that this is not just going to equal x. So this tells me that since this doesn't just equal x, that f and g are not inverses. So just to recap, in case you're kind of like, let me think about this. Okay, let's recap real quick and just remind you that the only time you're going to move on to the second step where you actually do g of f of x is when the first composition, in other words, f of g of x equaled x. In that case, we moved on and we made sure that g of f of x also equaled x, and therefore, since both compositions equaled x, f and g were inverses. But if f of g of x was not just x, then there was no reason to even move on.